everyone, welcome back to another Math9 video. We are doing 6.6 applications of linear inequalities today. This is the last portion from chapter 6, and we're just going to run through a few quick examples, and there's a couple of vocabulary terms I want to mention here. So the first one we're going to start with is interpolation. So that's this one here, which is finding an unknown value on a graph that's between 2 points that are given. Extrapolation, on the other hand, is finding unknown values. Sorry, that should say values, not vowels, that are beyond the given points. So let's take a look at our first example. It says a 7-minute call costs 40 cents and a 10-minute call costs 80 cents. Plot the points and graph. 2, find the cost for 7 minutes of talking, and 3, find the cost for 17 minutes of talking. Okay, so in order to do this, let's take a look at I've already started the grid for you just to make this a little easier and clear. But let's talk a little bit about how we're going to plot this. When we go to make a graph, on the x-axis we would have the time, and on the y-axis we would have the cost here. So since the time in minutes, we're talking about here 7 minutes, then we're talking about 10 minutes, and if I look at the questions, it asks me about 7 minutes of talking and 17 minutes of talking. Sorry, this one should be 5 minutes. A 5-minute call costs 40 cents. So if we're looking for 7 minutes and 17 minutes, that means I probably want to make sure that my graph grows up to about 20 minutes of talking. So I know that on my x-axis, I want to go up to 20. So maybe going up by 1 is a reasonable amount or value to choose for each individual box or grid. So I've already labeled it and just written in 5, 10, 15, 20. And then for the cost, we're talking about values such as 40 cents, 80 cents, and then we know that it's probably going to be around a few dollars if we're looking at the values, because we're going all the way up to 17 minutes. If 10 minutes cost 80 cents, then 17 minutes, we get an idea of how much that's going to be. So to go up to $2 on the left-hand side here is quite reasonable. So now that we have our grid set up, I also have my title of my graph here, which is a good idea to do. So it says the cost of a call, because that's what we're using this for. So then we want to plot the points. A 5-minute call costs 40 cents. So if I zoom in on my graph, 5 minutes, at 5 minutes I want to go up to 40 cents, which is right there, because you can tell I'm going up by 10, 20, 30, 40, 50, so it's going up by 10 cents each time. So it makes sense that that's where my 40-cent mark would be. If I go back again to the question, it tells me a 10-minute call is 80 cents. So again, if I go over here on my x-axis to 10 minutes, then I would go up to from 50, 60, 70, 80. So there's my next mark there. And then I want to basically connect these dots to graph out what my line is going to look like. And I want to extend that line because I know that we are trying to extrapolate or find values that are beyond the ones that we have listed here. So there's the first step. We plotted the points and we graphed it out. And now we want to look for the cost of, let me underline it in green. We'll use our green to figure this out. We want the cost for 7 minutes of talking. So if this is in between the 2 points that we have listed, so it's in between the 5 and the 10 minutes, then this would be an example of interpolation. Just so that you're clear with what the definitions mean. So on my graph, I want to look, and I'm going to zoom in again, I want to look for the 7-minute mark. So 5, 6, 7, I'm dealing with like this X value here, and I want to go up on my line to whereabouts that would be. So when I look at the 7-minute mark, it looks like it's at about, right there. So if I look over to the left, that's at about 60 cents. So let me show you what I'm going to do. I'm going to show that it's approximately 60 cents with this squiggly equal to sign. That is not the correct terminology, but you get what I mean. The other way you could show an approximately equal to is using that symbol. It's an equal sign with a little dot on top, but I like the squiggly equal to sign. So let's use that one for now. So there's an example of interpolation. We looked in between the values given and we measured what the value is off of our graph. Okay, so then the next it's asking us for the cost at 17 minutes of talking. So again, I want to zoom in on my graph and I want to go to where the 17-minute mark is. So on my graph, here's 15, so 16, 17 is going to be about right here. And when I go to the 17-minute mark, I want to go up here approximately. So I'm going to, it really is approximate because you would use a ruler to get as accurate as you can with these points, but we're looking roughly to see where it would be. And so this is roughly at about, if you look, this was the 1-minute mark, 10, 20, 30, it's at about 35. So it's at about $1.35. So we go back to here. Again, this would be extrapolation, and it's at about $1.35. So there's an example of what extrapolation and interpolation means and how we would use that and apply that in a question. So basically the key thing I want you to get from this is how to read a graph. Well, I guess how to come up with a graph in the first place by plotting the points, and then how to use that graph to read and interpret some information from it. So there's our first example of what we're working with. And then moving on to another one, we have a situation where this graph is given to you. We're looking at Kate's jog, and we are comparing the time in minutes with the distance covered in meters. So it's already labeled for you, and again, I apologize, I just drew this by hand. So I've tried to label it clearly. The time in minutes, each box is a minute, so 1, 2, 3, 4. You can see why it's labeled here at 5. Each little box indicates 1 minute in time. And if we look at the other portion here, the y-axis, the distance here is given in meters, and so it goes up by 200 meters, 400, 600, 800, so each box represents 200 meters. So we can use that again to estimate. You'll notice that the question even says estimate because you can tell that this isn't going to be completely accurate and precise. Estimate how long it took Kate to jog 600 meters. So we want to look, we're kind of doing the opposite here, because if we're looking at 600 meters, we want to start off on the y-axis, and from 600 meters, we want to find like roughly where that would be. So it looks like it's about right there. So at 600 meters, we're at about 5 minutes. So you get the idea of how to use our graph in order to read the information that we need from it. Part B, how far did Kate jog after 4 minutes? Okay, so this time we're starting with the x-axis and we're reading the y-axis off of it. So if we're at 4 minutes, if I look at it, it looks like it's about right here. So it's in between the 400 mark and the 600 mark. So we could say for part B that it's around approximately 500 meters. which we're reading. Again, I could do this, I guess. Off to the side at the y-axis. That is at about, it's in between the 400 and the 600 mark, so we would say approximately 500 meters. Predict how long it will take Kate to jog 1,400 meters. Okay, so let's zoom in again on the graph here. So if we look at the 1,400 meter mark, that would be right here. And so we want to go off to the graph here on the side. Looks like it's about right here, and it's just past 11. Since we're approximating, it's okay for us to say that it is approximately 11 minutes. I'm laughing because this is an example I got from your workbook or from a textbook, but it's actually a little bit ridiculous because why is it taking Kate 4 minutes to jog 500 meters? That's actually ridiculous. We're going to assume that Kate has injured her ankle because it wouldn't really take 4 minutes to jog 500 meters. But that's okay. That's what the example is, so we'll go with it. So then for the last one, predict how far Kate will jog after 15 minutes. Okay, so again, we go back to our graph. I'm going to zoom in. After 15 minutes, okay, so on our graph, we're looking at where the 15-minute mark is, so it's about right here. And just for sake of accuracy or precision, we'll say that it's pretty much right on the line there. So right on the line would be at 1,800 meters. So again, approximately 1,800 meters. Okay, so I just want you to get a sense of how to interpret graphs, how to read them. So I'm just giving you only 4 questions from this section. So you can do numbers 2, 4, 6, and 7. And remember that once you are finished completing those questions, do flip to the back of the book and mark your work and check it as well. Anything you didn't get, please do your corrections and or get in touch with me through Microsoft Teams or email to ask questions.